So this lecture for section 6.1, MAC 1105. So composite functions is what we're going to be covering in this section. And so one of the things that I want to sort of talk about composite functions is that this part right here is called f composed of g of x, right? And then this part over here, which they're the same, is f of g of x. Now I tend to use this notation, so sometimes I will go back and forth, but this notation here is a little easier, especially for those of you who might go on to take applied calculus. So basically, a composite function is a function that's created by combining two functions. So if I do the first one, f composed of g of 4, what I'm going to do then is what this is asking me to do is to find f of g of 4. That's really what it's asking us to do. And so what we're going to do here is we're going to go ahead and find out, well, what's g of 4? Well, g of 4 is 3 times 4 to the second power plus 1. And so g of 4 is going to be 49. So then, since f of x is the outside function, and this becomes 2 times 49, which is going to be 98 for part A. And so that's how you do these types of problems. For part B, I'm going to find g of f of 2. Right? That's what it's asking me to do here. So then, first thing I can do is find f of 2. And f of 2 is going to be 2 times 2, which is 4. So then g of 4 is going to be 3 times 4 to the second power plus 1, which is 49. So g of f of 2, is equal to 49. So part C, what they're asking us to do is f of 1. So then if I can calculate what f of 1 is, it's going to be 2 times 1, which is 2. And then f of 2 is just going to be 4, right? Because we're just going to take the value of the inside function and then put it into the outside function. So part D, I'm going to find g of 0. So g of 0 is 3 times 0 squared plus 1, which is 1. So then here I'm going to find g of 1, which is just 3 times 1 to the second power plus 1, which is just going to be 4. And so that's how you do number 13 for all 4 of these. For number 16, we're going to go ahead and do the same thing. I'm going to do the same thing for finding these particular values. So first I'm going to find f of g of 4. And so the first thing I'm going to do is I'm going to find g of 4, which is 1 minus 3 times 4 to the second power, which is, in that case, it's going to be negative 47. So I'm going to find f of negative 47, which is going to be 4,418. So you take those values, plug them into the outside function. So that's how you do part A for that one. So for part B, I'm going to do g of f of 2. F of 2 is going to be just 2 times 2 to the second power, which is 2 times 4, which is 8. So we're going to go ahead and find g of 8. And so g of 8 is going to be 1 minus 3 times 8 to the second power, which is 1 minus 192, which is negative 191 for part B. Part C is going to be f of 1. So if I find out what f of 1 is, that's going to be 2. So I'm going to find f of 2, which is going to be 2 times 2 to the second power, which is going to be 8. And in part D, I'm going to find g of 0, So g of 0 is just going to be 1, right? Because 3 times 0 to the second power is 0, and then 1 minus 0 is 1. So I'm going to find g of 1, which in this case is going to give me negative 2. So that's how you do number 16. Let's jump over to number 18. So this time they're not asking for anything else other than just, plug in these values. So for A, I'm going to find f of g of 4. So g of 4 is going to be 12, right? 3 times 4. So I'm going to find f of 12, which is 12 plus 1, which is square root of 13 for part A. For part B, I'm going to find g of f of 2. So I find out what f of 2 is. 2 plus 1 is the square root of 3. So I'm going to find g of the square root of 3, which is just going to be 3 square roots of 3. Part C, I'm going to do the same thing here. So part C is going to be f of 1. F of 1 is going to be the square root of 2, right? I'm going to find f of the square root of 2, which in this case is just going to be square root of 2 plus 1 for part C. And then for part D, it's going to be g of 0. So g of 0 is 0. And again, g of 0 is just going to be 0 for that one. And that's how you do number 18. So looking at number 21, we'll do the same thing. All right, so part A is going to be f of g of 4. So what is g of 4? So g of 4 is the cube root of 4. And so this one is just going to be 3 over cube root of 4 plus 1 for A. For B, I'm going to find g of f of 2. So f of 2 is going to be 3, and that's just going to be 1. So I'm going to find g of 1, it's cube root of 1, which is 1 for part B. For part C, I'm going to find f of 1. So I find out f of 1 is, which is going to be 3 over 2. So I'm going to find f of 3 halves, right? And so I can go, let me just move this out the way here. And so for this one here, what I can do is I can combine this. So it's going to be 3 over 2 plus 2 over 2, which is 5 over 2. Then 3 over 1 times 2 over 5, which is 6 over 5. So that's part C for number 21. Let's look at part D. So part D is just going to be g of 0. Cube root of 0 is 0. Oops. Let me do it this way. G of 0 is the cube root of 0, which is 0. And then, of course, g of 0 is just going to be 0. That's how you do number 21. So for number 24, what they're asking us is not only to find the composite functions, but also to state the domain. So what I'm going to do for number 24 is that the domain of f of x is basically x is a real number, or x is any real number. And the same thing for g of x, right? The domain of g of x is also that x is any real number. In other words, I can plug in any value for an f or g, and I'll be okay because I'll get a real number out. So for part A, they're asking us to find f of g of x, which is going to be, right, we want to replace the x with that, so it's going to be negative 2x plus 4. And so the domain of this one, since it's a polynomial, is x is just a real number, right? Any real number. For b, I'm going to find g of f of x. It's going to be 2 times negative x minus 4, which is negative 2x minus 4. And again, the domain for this one would be x is any real number. I'm just abbreviating there so I can have some space. So for the next one, it's going to be f of x. So it's going to be negative x, which is just x. And again, the domain for that would be x is any real number. So far we have had no restrictions for the composite functions. So for part D, I'm going to find g of x, or g of x, yeah, g of x. So it's going to be 2 times 2x minus 4, which is 4x minus 8 minus 4, which is 4x minus 12. And again, the domain of that is x is any real number. Because all of them are polynomial, so the domain will be any real number. So for number 26, we're going to do the same thing. So again, f and g, their domain for each one is not restricted. So in other words, x can be any real number. And so for part A, we're going to find f of g of x. Which is going to be x squared plus 4 plus 1, which is x squared plus 5. And the domain of that is x can be any real number. So for part B, we're going to find g of f of x. So it's going to be x plus 1 to the second power plus 4, which is x squared plus 2x plus 1 plus 4, which is x squared plus 2x plus 5. And again, the domain for this one is also going to be x is any real number. So for part C, we're going to find f of x, the x plus 1 plus 1, which is just going to be x plus 2. And again, no restrictions in the domain because, again, it's a polynomial. So for part D, it's going to be g of x. Inside function is going to be g of x. Outside function is g of x. And it will be x squared plus 4 to the second power plus 4. Then this becomes x to the 4th plus 8x squared plus 20. And again, so that one, of course, you would have to do x squared plus 4, x squared plus 4, which is x to the 4th, 4x squared plus 4x squared plus 16, and then that's how you get the 20. 16 plus 4 is 20, and then 4x squared plus 4x squared is the 8x squared. So for number 30, we have rational expressions now here. So we do have some restrictions, right? And so for f of x, the domain is any real number as long as x does not equal to negative 3. So negative 3 cannot be in the domain of f of x. So g of x is x cannot equal to 0. So those are two restrictions for both of those. So now we're going to find f of g of x, which is 1 over negative 2x plus 3. I'm going to clean this one up a little bit. So this is going to be negative 2x plus 3x over x. So then this one's going to be negative 2x, so it's going to be negative 2 plus 3x over x. And so it's just going to be 1 over 1, and then x over negative 2 plus 3x, which is just going to be x over 3x minus 2. And so the domain for this one, we have to look at the inside function. So it's x cannot equal to 0, so it's going to be the domain of g. And then, of course, x cannot be equal to 2/3, because if I set this equal to 0, I get 2/3, right? That's going to make it 0. So for part B, for this one, it's going to be g of f of x. So then that's just going to be -2 over 1 x plus 3. And so what I can do here then is going to be -2 over 1 times x plus 3 over 1, which is -2 x plus 3. So since f of x is the inside function, x cannot be equal to -3. So you have to account for the domain of the inside function and then whatever restrictions you have for the composite function that you created. So I'm going to go ahead and do part C. I'm going to skip part D, and this is just going to be f of x. And so it's just going to be 1 over 1 x plus 3 plus 3, just 1 x plus 3, and then plus 3x plus 3 over x plus 3, which is going to be 1 plus 3x plus 9 over x plus 3, right? And then so this is going to be 1 over 3x plus 10 times 1 over x plus 3. And so what I'm going to have here for this one, when I combine those two, is just going to be, sorry, I'm not going to, let me do this one again. And so oh, sorry, I rewrote it wrong here. I knew something didn't look right. So then it's going to be 3x plus 10 over x plus 3, which is just going to be x plus 3 over 3x plus 10. Sorry about that. So then the restriction is going to be, of course, though, from the inside function, which x cannot be equal to -3, and then x cannot be equal to -10 over 3, which is from the new function itself. Okay, so for number 40, what we're going to do here is we're going to find out whether f of g of x is equal to g of f of x. So that's what we're trying to find out here for number 40. And so what we do is we're going to see if f of g of x, so it's going to be 4 times 1 over 4x, which is just going to be x. So that was easy. Now g of f of x is 1/4 x times 4x, which is also x. So then in this case, f of g of x is equal to g of f of x, which is equal to x. So let's do it here for number 44, right? So we're going to go ahead and find out what's f of g of x. 4 minus 3 times 1/3 times 4 minus x. So that's going to be just 4 minus x, which is 4 minus 4 plus x, which is equal to x. Now g of f of x is equal to 1/3 4 minus 3x, which is 1/3, and then 4 minus 4 plus 3x, which is just going to be x. So in this case, again, f of g of x is equal to g of f of x, which is equal to x. Now for the last two for this section, what we're going to do is we already have a composite function. So in other words, they said that f of g of x is equal to h of x. So g of x is the inside function. So if g of x is the inside function, then what I'm looking at is just this part right here. So then that means that g of x is equal to 1 over x to the second power. And then f of x has to be x to the third power. So if I were to do this, then I would say, okay, so that's going to be 1, that's my inside function, and that's my outside function. Same thing here, right? F of x is my outside function, which is going to be the square root of x. And then g of x is my inside function, which is 1 minus x squared. And so that's how we do 6.1. Thank you.